Hello. In this episode, we will work on the front end with our app, and I will show you how to pass data via props, type it safely with TypeScript, render the lists with V4, assign unique identifiers, and simplify logic by moving simple conditions into the template sections. You will also see the difference between working on the same reference and a shallow copy, and how that affects component behavior. Alright, let's get back to programming. We paused for a moment to improve our project and development environment, but now we can continue. Using our script or alias, let's launch Visual Studio Code. For now, we won't be using the backend, so it can be closed. At this point, I'd like to go over how the front end works and also discuss a few elements that will be useful when building the application. If you would like to follow along with the course and reproduce the same steps I'm showing on the screen in the video, make sure to switch to the feature S01E08-start branch. As you may recall, at this stage we have a fairly simple application consisting of a few components. There is a parent component that has children and can instruct them to spin so they start rotating. The children in turn can signal that they are hungry. This gives us a chance to go over communication between the parent component and its children, as well as how the children send information back to the parent. Let's try to expand our application a bit. Having just one parent with 3 children is a rather artificial example, and it doesn't really feel like a complete application. So let's assume we have 2 parents. I will place them side by side using the Tailwind framework classes we discussed in the previous episodes. Let's clean this up a little. I will get rid of that big margin on the parent and instead just add some padding around the whole block that holds the parents. As you can see, each parent component that we duplicated works independently. That's because every one of them is its own instance. So when a parent tells its child to spin, it only affects the children inside that specific parent. Now, the problem here is that both parents currently have exactly the same children. That doesn't really make sense, and it's not something you would expect in the real life either. We need to separate this. Each parent component should know which children it has and only display those. That way, one parent can have one set of kids and the other parent can have a different set. To do this in our script, we will create variables to define those children. I will call them P1 kids and the P2 kids for the first parent and the second one. For now, let's just comment out those variables. We will come back to them in a moment. As you remember, our child component accepts several parameters. These are the name, the boolean value is spinning, the boolean value is hungry, and the skin color. These are the parameters we work with, and this is how we handle the data. In our children's data stored in the P1 kids and the P2 kids arrays, we need to include exactly this information. Each child will be represented as an object containing the basic data: name, is spinning, and is hungry. For now, we skip skin color since it already has a default value. Additionally, each child will be assigned a unique identifier. For the first parent children, it will be P1 child name, and the second parent's children P2 child name. Here we assume that parents do not give their children the same names, so we can be confident that these identifiers will always be unique. Once we have our children defined, we need to pass them to the parents as a parameter. Each parent will have a kids parameter into which we pass the appropriate array of children. Apart from passing the data, we also need to handle this parameter inside the parent component by defining the appropriate props. So here I add props kids just as we pass the information, and it will be an array of child objects. As you can see, we have generated an error. This happens because earlier we defined this type as a child props, so I'm changing it to child because it's clearer and more straightforward, just as you can see in the video. After renaming the interface in the types file and fixing the imports, everything looks correct, and now we don't have any errors anymore. So let's enjoy this moment, because usually in development an error-free state of the app only lasts for a short while before the next change comes along.
And that's an absolutely true story.
In the child data, I have added a unique identifier for each child. This becomes especially important when working with loops because it helps Vue.js handle lists more efficiently, both when rendering them and when updating reactive data. Adding unique IDs is simply the best practice here. The only things left is to include the ID property in the child interface so that I can pass it along whenever I am working with child lists. Now let's move on to our parent component, parent.vue file. In the template section, we currently have the child components listed one after another, each with its own parameters for styling and behavior. Let's remove those because from now on we will be working with external data, and more specifically with the props kids parameter. That's where we keep the child information stored in an array. In Vue.js we use the v-for directive to render lists. It's the directive that allows us to loop over arrays and generate multiple elements based on the data. The syntax is pretty straightforward. Item in items, where items is the source data array and item is an alias for each element in that array. In our case, we will do exactly the same. V for kid in kids, where kids refers to the kids property that comes into the parent component. As you can see, our component is currently underlined in red. That's an error. It's a TypeScript error, and it totally makes sense. We are instanting an empty child component without the required props. And we know child needs those to work correctly. This is a great example of how TypeScript helps in practice. It immediately points out the problem and guides us toward the correct usage of the component. So let's pass the required props to our child component. We will need ID. This helps Vue manage list rendering. Name, the child's name. Is spinning, whether the child is spinning. And is hungry, taken from kid.isHungry. You can see there is an error here. Let's take a look at what's causing it and why. First, let's check our types. In the child interface, we are missing the isHungry property, so let's add it. There is still an error, so let's look again. It turns out I named the variable incorrectly and did not follow the camel case convention. I will rename it to isHungry with the capital H, and now everything should be fine. The last prop that the child component can take is skin color. This one is optional, which means it's not required, but we can pass it if we want. I am setting it as a kid.skinColor or undefined. If the array does not contain a skin color property, we will pass undefined. And in that case, the child component will simply fall back to its default value for this property. Okay, as you can see, props kids in the parent component is still underlined in red, which means we still have an error here, and of course this happens because in one of the child's attributes, instead of using camel case as it was defined in the type, I wrote it in a lowercase, and that's exactly what causes the problem. Okay, we still have a problem with the second parent component. A smaller mistake, which definitely does not affect this issue, is the child's identifier. Let's change it to the correct one, P2 Chris, but as you can see, the error is still there. If we hover the cursor over the underlined error, the exact description appears. We see the message: types of property skin color are incompatible. The type string is not assignable to type skin color or undefined. This clearly shows that the value passed to the skin color in one of the children is a plain string instead of the expected type. So let's see what values we can provide here. As you can see, skin color is not a string type that would allow us to pass any class and any child skin color. We have a set of predefined colors that we can use. And these are typed in class names, as you can see in the video. Let's look at one more detail. Even if I fix the skin color value to the BG green 800 in the first array element, TypeScript still reports an error for the second parent in the kids property. This happens because at the parent component level, TypeScript can't be certain that the value we pass is actually allowed. We are typing valid data, but TypeScript doesn't analyze array contents for specific values. It only sees types, and here skin color is just a string. A plain string is not the same as a predefined set of allowed values I mentioned earlier. To get rid of this error, we need to be more explicit about the types used in the P1 kids and P2 kids arrays. Let's define them so that skin color isn't an arbitrary string, but one of the specific options our component accepts. You can also see that the first parent component doesn't show an error on the kids property. That makes sense because the P1 kids array doesn't include the skin color attribute since we don't pass it. And the remaining fields and values match the type definitions. So the TypeScript has nothing to complain about here. Let's now tell TypeScript what type the variables are and what kind of data is stored in the P1 kids and P2 kids arrays. As you can see, the moment I added the type by placing a colon after the array's name, the error disappeared. This happens because TypeScript now expects a type to be specified and can therefore go back to checking whether the kids parameter in the parent component is correct. If we had specified a different parameter type, not child, then of course the error would have appeared again. But now everything works correctly. Both parent components no longer shows any errors. We got one more benefit from this declaration. As you can see now, when we set skin color to a disallowed value, the error shows up directly in the array next to the specific entry. Earlier, it was not as clear because we saw the error on props kids in the parent component, since only at that level TypeScript noticed the invalid skin color value. Now, thanks to the explicit child type declaration, we immediately see which array element and which value in our variable is wrong. This really simplifies finding and fixing errors. Alright, let's change skin color to a valid value, and once we have cleared all the errors, we can move on. There is still a bit of work ahead of us. In the parent component, we previously had two buttons. Clicking them determined whether the child would start spinning or not. Now we can have any number of children, and just like with the child component, we also need to program the buttons so that each one controls the right kid. We will use the v-for loop again and set the button identifier to kid ID. This way each button will have a unique identifier that matches its corresponding child component. At the start of the identifier, we will add the button prefix so that buttons and components each have their own separate unique identifiers. Now we will add a value to the button on click. This time we will toggle the isSpinning value to its opposite. That way, with a single click and a single button, we can handle both events, starting the child spinning and stopping it. As you might remember earlier, in the code we displayed different text on the button depending on whether the child was spinning or not. For that we used computed values such as child1 button text and child2 button text which depended on the child1 spin and child2 spin variables. We no longer need this approach. Instead, we can simplify the code by adding a condition directly in the template to switch the button text. Moving the condition that changes the button text into the template section has its pros and cons. In our case, it simplifies the code and the expression is still clear and easy to understand for other developers working with us. However, if we wanted to add more complex logic or advanced operations for managing the button text or handling additional events and values, then even though it is technically possible to keep it in the template, it is better to place it in the script section. That is the dedicated place for JavaScript code and where such logic should live. So when moving code into the template, it is important to do it in the moderation and avoid putting too much logic directly into template. So let's add two span elements inside our button, and each of them will display different content. We will use the vif and velse directives, which allows us to define what should be shown depending on the value of the isSpinning parameter in the kid object. If this parameter is set to true, we will display the text stop spinning along with the child's name. If the value is false, we will show the text spin together with the child's name. So as you can see on the screen, the structure is really simple and easy to follow. The most important thing is that the code we write should be clear and readable for others as well. Right now there is still a bit of unnecessary stuff here, but we are going to clean that up in just a moment. But before we move on, there is one more thing we need to take care of that I have not mentioned yet. As you can see, in the parent component, the list of children is built using the loop v4kid_in_kids. Theoretically though, we do not actually have a variable called kids in our code. In the whole setup section, we never define a variable named kids, we only have the props where the array of children is located. What is more, if we hover over props with the cursor, we can see the message that this variable is declared, but its value is never read. So the question is, why does the loop v4kid_in_kids still work correctly? If in the template section we build our loop using v4kid_in_props.kids, the script still works correctly, the loop executes without any issues, and the children are displayed. On the top of that, we get rid of the warning related to the props definition. At this point, we no longer see the message saying that the props variable is declared but never used, because now it's actually being referenced. Let's bring back the previous state and now change the way we declare the variables that our component can accept, meaning the props. We will do it in a less declarative form without assigning them to any variable. This is a perfectly valid way of defining props in Vue.js components, and we can use it without any problem. With this approach, our loop v4kid_in_kids still works correctly. If we define the loop in the template as v4kid_in_props_kids, then in theory it should not work in our current setup, because there is no props variable in the code. In our case it does work. In a moment we will see why. The editor with code suggestions completed the snippet for me, which I did not notice, and added a props variable. In practice, it assigned the results of defineProps to a local props variable, so the props.kids reference in the template makes sense and everything renders. When we declare the props in the form I intended, which is without assigning them to any variable, props no longer exist in the template scope. At that point, props.kids is no longer valid. As a result, the component throws an error during server-side rendering and we see a 500 status. That is the exact reason for the difference in behavior. Alright, let's bring our code back to the previous version. This was a simple detail that I just wanted to highlight for you. Now I would like to show you one more thing that can be important to keep in mind. Sometimes it can generate so-called side effects and cause strange behavior in components if we don't know where it comes from. Now we have the loop v4kidInKids that builds the list of children and directly refers to props.kids, which are the parameters passed into the component. There are cases where we may want to process this data before rendering it. In our example, let us assume we want to add a new child to the array at the parent component level before it appears in the view. To do that, I will assign the value of props.kids to local kids variable inside the parent component, as you can see on the video. This lets us perform the necessary operations on the data and only then render it. Let's now add another child object with some sample data to our local kids variable. After adding it, as you can see, both parent components generated an additional child based on the updated value of the kids variable. Let's now change our loop to directly reference props.kids, so v for kid in props.kids, and here is an interesting point. As you can see, the parent components still render the children that we passed in the props along with the additional child. This happens even though we are building the loop based on props.kids, which does not yet contain that extra element. So why does this happen? The answer to why this happens is reference. When we assign the kids variable in the way you see here in the video, the reference inside ref points to the exact same array that we received in props kids. So when we call kids value push and add a child object, we are actually inserting the element directly into the props array. That is why the loop v for kid in props.kids immediately sees the new child and renders it. The component behaves differently if we define our local kids variable in another way and create what is called a shallow copy of the list of children passed in props.kids. We do this using square brackets, 3 dots, and the props.kids variable. In this case, our local kids value and props.kids are two separate arrays. If we add an element with the kids value.push, we only modify the local copy while props.kids remains unchanged. Since the loop in the template iterates over props.kids, we will only see the children that were passed in the props without the newly added element. As you can easily guess, if we build the loop based on the local kids variable, we will also see the additional element that we added in the code. I hope this example makes clear the relationships between variables and what a reference means in Vue.js. I do not want to judge here which approach is better. In theory, the props that we define with defineProps are and should be read-only, so we should not modify them. If we do need to, it is better to create a copy. Still, it all depends on the context in which we are working. For you as a developer, the most important thing is to be aware of how this works and what to expect, what you can make use of intentionally, and what may cause problems and lead to potentially unexpected behavior of your components. Let's remove the sample child that we added in the component. We no longer need it. Now let's move on to the next topic I wanted to quickly discuss. First, let's fix the buttons, which as you can see have stopped working because the logic for building child components in the parent component has changed. In the template section, as you remember, we have two buttons responsible for spinning the children. Now that we can pass any number of children through the kids prop, we also need to build the buttons accordingly. We will use a v4 loop here, nothing new, and we will iterate over the kids variable, so v4 kid in kids. Visual Studio Code suggests using kid.id as a key. And that works fine. However, I want to draw your attention to a small detail. For better safety, readability, and to make sure Vue correctly identifies the elements in the DOM tree, it is good practice to create truly unique identifiers. I add the prefix button and then concatenate with kit ID. This way I can be sure that the button identifiers are unique. Now let's prepare the action that will be triggered when the button is clicked. This is a very simple operation where we toggle the value of the isSpinning field in the kit object, changing it from true to false or from false to true. In addition, inside the button we will display text that tells the user whether the child should start spinning or stop spinning. We will also include the child's name, which makes the button clearer and improves usability for the user. After saving the file, the buttons are now generated dynamically. For each parent component, the number of buttons matches exactly the number of children passed in the props.kids parameter. I will also make a small correction and adjust the children's names so that they start with a capital letter where they do not. I will also fix the spelling of the name Chris because in English it is written with CH. After saving the changes, everything works correctly, as you can see. Just as we wanted, the buttons trigger the right actions, although these are very simple operations that do not require much code analysis. I would like to point out, however, that by moving some of this simple logic into the template section, we have simplified the script section and at the same time made it more readable. That's why whenever we deal with simple situations and simple code, it is worth considering whether it is better to place it directly in the template. This is of course a matter of individual approach and project decisions, and ideally it should also be discussed and agreed in the team on the approach and the basic rules we want to keep. I have already mentioned this in previous episodes, so I am sure you remember it. Okay, that's all for today. To wrap up, we learned how to separate data between parents, type the child shape, build list in the template, provide stable keys, handle click actions, and choose deliberately between a reference and a copy. In the next episode, we will streamline the code even further, and I will show you how to manage application state and display data using Pinia storage. For now, that's all. Have a great day and see you soon.